Welcome to the lecture entitled Scientific Explanation, Preliminary Issues. I'm Andrew Chapman. In this lecture, we'll look at a number of the preliminary issues that are necessary for understanding the broader issue of scientific explanation and that must be understood fully in order to look at more complex issues such as different theories of scientific explanation. We'll look at these preliminary issues by examining 8 topics. 1. Postmodernism, pragmatism, and realist conceptions of science. 2. The relation between scientific success and scientific explanation. 3. The relation between explanation, demarcation, methodology, and progress. 4. The uniqueness of scientific explanation. 5. How to investigate the nature of scientific explanation. 6. Investigative goals and proprietary terminology. 7. The relation between explanation and prediction. And 8. Traditional elements of scientific explanation. Most discussions of the nature of science start with the fact that science at least appears to have been very successful. Take, for example, modern medicine, communications technology, and the ability to make war. But this appearance requires investigation in terms of 2 specific questions. 1. Has science actually been successful, or does it merely appear to be successful? And 2, if science actually has been successful, then in what sense has it been successful? To ask whether and how science has been successful is not to be a science denier, but instead to be intellectually honest in our support of science. First, actual science deniers won't be persuaded by being called names. They'll be persuaded when they can be shown reasons to change their minds about science. Second, simply to trust science without being able to explain why someone ought to trust science is to display the same dogmatism displayed by, for example, client science skeptics and creationists. And third, if something is worth respecting, then it's worth understanding. There's a long tradition in the philosophy of science, political philosophy, and philosophy more broadly that says that respecting something requires taking it seriously enough to offer criticisms so that we can improve the thing. So, has science been successful, and if so, how? 3 of the most popular overarching theories about the nature of the scientific project in general are postmodernism, pragmatism, and realism. The definitions that I give here will necessarily be broad and also short. There's much more to say about postmodernism, pragmatism, and realism than I'll be able to say right here. Postmodernism in the philosophy of science, exemplified by philosophers such as Thomas Kuhn, holds that science has no nature other than the one contingently given to it in the moment by the scientific community. There are no objective standards. What's called good science is whatever the scientific community claims is good science, and thus all standards are merely subjective. Pragmatism in the philosophy of science, exemplified by philosophers such as Larry Loudon, defines the nature of science in terms of science's ability to have specific consequences, such as, for example, solving specific problems. Realism in the philosophy of science is the traditional view that science has a specific nature, even if we can't quite figure out what that nature is, and that the goal of science is to say true things about the way the world actually works. At first glance, postmodernism seems ultimately democratic and sensitive to the practice of actual scientists. Postmodernism doesn't appeal to unchanging standards such as truth or rationality, and as such, it can seem like the ultimate defense against intellectual tyranny. In fact, many prominent supporters of postmodernism in the history of philosophy, the history of the philosophy of science, and the humanities more generally were reacting against intellectually tyrannical or dictatorial pictures of truth and rationality, where the claims to have found truth or to be operating in a rational sense were used so as to elevate certain people over other people. However, in throwing out the possibility of any standards, postmodernism at best simply says that there's no such thing as the philosophy of science. All that's possible, according to postmodernism, is the history, sociology, and psychology of science used merely to describe what people are actually doing. But how could it be possible for mere descriptions of the practices of actual scientists to tell us anything about why science is successful? Even further, since science requires philosophy, because philosophy helps science keep itself in check and continue forward as a coherent discipline, a conclusion of postmodernism seems to be that since philosophy is impossible, science is also impossible. Postmodernism seems less a position in the philosophy of science than a complete refusal to engage with the philosophy of science to begin with. For these reasons and many others, most philosophers have given up on postmodernism, and there are almost no postmodernist philosophers of science who are continuing to produce groundbreaking work that pushes forward our understanding of science. While it's true that science has resulted in many discoveries that themselves have had specific consequences, are we really sure that all science does can be cashed out in terms of the consequences of science? The traditional picture of the scientific progress is that there's a division between what we can call pure science, science that aims at understanding and explanation, and what's called applied science, science that does things based on the understanding and explanation produced by pure science. Pragmatism seems to claim that there is no such thing as pure science. All there is applied science. But we might wonder, how could we explain applied science's ability to do things if not in terms of pure science's promotion of understanding and explanation? Isn't it true that science can only do things because science increases understanding? Thus, the main problem here for pragmatism is that pragmatism focuses on the results of applying scientific discoveries, but doesn't focus at all on scientific discoveries in terms of understanding or explanation, and in fact claims that there are no such things as understanding or explanation. For this reason, most people have given up on pragmatism. A standard realist answer that's been given to the question of whether and how science has actually been successful comes in terms of the notion of scientific explanation. The realist thought is that science's job is to aid in understanding the world, and that this understanding is accomplished via explaining why the world works the way it does. Contra pragmatism, this realist picture holds that the consequences of scientific investigations are only possible because of science's success in explaining the way the world is and in aiding in understanding how the world actually works. Contra postmodernism, this realist picture holds that science wouldn't even appear successful unless scientific explanations weren't getting it at least minimally correct in some objective sense. Thus, the claim of the standard scientific realist is the criterion of success for science is explanation. And since science has given many good explanations of natural worldly phenomena, science has been successful. This picture of science as aimed primarily at explanations offers a succinct and plausible answer to questions of demarcation, methodology, and progress. If explanation is at the heart of science, then science's essence is explanatory in nature. In terms of demarcation, fields that give specific sorts of explanations are scientific. In terms of methodology, scientists ought to attempt to give specific sorts of explanations. And in terms of progress, science progresses when it gives more and better explanations of a specific sort. And also, this picture of the essence of science has the benefit of matching the actual practices of contemporary scientists. Scientists really do seem to be trying to explain the world in a very specific sort of way. Now, we've been saying that science gives explanations of a specific sort. Why is it that we've been making this qualification? Well, there's good reason to think that one of the things that separates different explanatory disciplines, that is, disciplines that give explanations from one another, is the sorts of explanations given. Thus, the sort of explanation given by an explanatory discipline can serve to demarcate that discipline from other explanatory disciplines. Even further, however, there's good reason to think, and most scientists certainly do think, that the explanations given by science within its particular domain, namely the domain of natural phenomena, are better than competing explanations given by non-scientific disciplines. Thus, science claims a sort of priority over explanations of natural phenomena, since science claims its explanations are the best ones available of natural phenomena. Thus, an investigation of scientific explanation isn't just an investigation of one huge part of what practicing scientists and historical scientists are and have been up to. It's also an investigation into scientific methodology, scientific progress and the nature of science itself. An investigation of scientific explanation is an inquiry into the nature or the essence of scientific explanation. In order to search for this nature or this essence, we should start by analyzing the notion of scientific explanation. Such an analysis of the notion of scientific explanation will result in an explication of explanation. An explication is a completed analysis of a thing, and explications make explicit the nature of that thing by providing the necessary and sufficient conditions for something to count as that thing. Thus, explications make explicit. We're trying to make explicit the nature of explanation. Thus, we're looking for an explication of explanation. Thus, when searching for the nature or the essence of scientific explanation, we should attempt an explication of the notion of scientific explanation. Thus, explication will result in the necessary and sufficient conditions for something to count as a scientific explanation. A condition is a test that something has to pass. So, to meet a condition is to pass a test. A necessary condition is a condition that a particular thing has to meet in order to be the sort of thing that it is. Thus, if X is a necessary condition for A, then anything that is in A meets condition X, and nothing that doesn't meet condition X is an A. So, for example, being warm-blooded is a necessary condition for being a mammal. All mammals are warm-blooded, and no things that are not warm-blooded are mammals. A sufficient condition, on the other hand, is a condition such that anything that meets that condition is some particular thing. Thus, if Y is a sufficient condition for B, then anything that meets condition Y is a B, and nothing that is not a B meets condition Y. So, for example, being a square is a sufficient condition for being a rhombus. All squares are rhombuses, and nothing that is not a rhombus is a square. It can help to think of necessity and sufficiency relations as relations of inclusion. So just remember this diagram. Being inside the smaller circle is sufficient for being inside the larger circle. All things that are inside the smaller circle are inside the larger circle. And being inside the larger circle is necessary for being inside the smaller circle. Something can't be inside the smaller circle without being inside the larger circle. These concepts of necessity and sufficiency aren't mere academic curiosities. If you confuse necessity with sufficiency, you are prone to make all sorts of mistakes. So, for example, while it's true that cowards might refuse to fight in some particular situation, being a coward is sufficient for not fighting, that doesn't mean that all people who don't fight in that situation are cowards. Being a coward isn't necessary for not fighting. Maybe it's not the sort of situation where fighting is prudent. However, we see people all the time, and especially in politics in the United States confuse sufficiency and necessity with one another. Oftentimes, when we're searching for an explication of something, what we'll be looking for is a set of a few conditions that are individually necessary and jointly sufficient for that thing. This phrase, individually necessary and jointly sufficient, is one that shows up quite a bit in discussions of the nature of explanation in philosophy of science generally and philosophy broadly. Imagine that you're starting a bonfire. You get together some paper, some small branches for kindling, and larger logs for burning, and then you use a match to light the paper, and your bonfire gets going. If you were missing just one of the elements, paper, the branches, the logs, the match, not to mention, of course, oxygen as well as a few other conditions, your bonfire couldn't have resulted. What that means is that each of these elements was individually necessary for your bonfire. And once you got all of the elements together, you had a bonfire. Thus, the entire set of elements was jointly sufficient. When we talk about things being individually necessary, that means on their own, each one of them was necessary. When we talk of things being jointly sufficient, that means when you got them all together, you had a set that was sufficient, but on their own, maybe each one of them wasn't sufficient. Thus, when we're searching for a set of conditions for something to count as a scientific explanation, we'll often be searching for conditions that are individually necessary, meaning anything missing even one of these conditions couldn't be an explanation, and jointly sufficient, meaning anything that has all of these conditions is an explanation. Conditions for something to count as a scientific explanation. Within the philosophy of science, the topic of scientific explanation possesses a few proprietary pieces of terminology. These pieces of terminology, despite being somewhat odd at first glance and in Latin, are used so as to keep discussion of the very important issue of scientific explanation clear, precise, and standardized. When seeking a scientific explanation, what is sought is an explanation for a specific natural event. Something happens that calls out for explanation. This natural event that we are seeking to explain is known as an explanandum, and the plural of explanandum is explananda. When giving a scientific explanation for some specific natural event, we point to facts, properties, truths, or other events that do the explaining. The thing that does the explaining is known as an explanans. The plural is explanantia. Now, even though explanans ends in an S, it's singular. That's very confusing for those of us who don't know Latin. So explanans, that's one thing. If you've got more than one explanans, you've got explanantia. There is no such thing as one explanin. You have one explanans. So to put these terms together, an explanandum is explained by an explanans, or by a few explanantia. Scientific explanation is closely related to another concept, scientific prediction. Science's success in terms of its explanatory abilities is also articulable in terms of science's predictive abilities. So take modern medicine as an example. Science helps researchers and doctors not only by explaining how the human body works, but also by predicting how the human body will respond in particular conditions. Scientific explanation is a backward-looking process. Phenomena are explained by appealing to things that occurred before those phenomena. Scientific prediction, on the other hand, is a forward-looking process. Things at the present moment can be appealed to in predicting phenomena that will come after those things. Very broadly, then, we can think of explanation and prediction as two sides of the same coin. Prediction is essentially forward-looking explanation, and explanation is essentially backward-looking prediction. When we look at contemporary scientific explanations and at the history of scientific explanation, there are a few elements that traditionally show up as explanantia or as components of explanations. Now, of course, the fact that these elements traditionally show up doesn't mean that they should show up, that they ought to be components of scientific explanations. We'll actually need to do some philosophy of science rather than just some history of science in order to determine what a scientific explanation should look like. However, as we've noted, part of searching for an explication of scientific explanation involves looking at the sorts of explanations scientists have in fact given and do in fact give. The elements that traditionally show up most often in explanantia are causation, natural laws, and initial conditions, also known as boundary conditions. While we won't get into each of those here, understanding traditional explanations and traditional accounts of explanation requires understanding the nature of each of these traditional elements, as well as the part that each of these traditional elements is supposed to play in scientific explanations, in the history of science, and in the present. Finally, a note on epistemology. Epistemology is the philosophical subdiscipline that studies the nature of knowledge and of justification. An epistemology is a theory concerning whether and how knowledge and justification are possible. Even though the goal of explanation is generally concerned with seeing the world objectively, explanations themselves are human-centered things. It's humans that request, provide, understand, and employ explanations. Accordingly, any investigation into the nature of scientific explanation either is or will require epistemological work. Whichever epistemology, that is, whichever theory concerning knowledge and justification, we think is true, will dictate which pictures of explanation are plausible and which aren't. If our epistemology holds that knowledge is only possible in some way, call it way X, and not in some other way, call it way Y, then we shouldn't adopt a picture of explanation in which explanation relies on our having knowledge in way Y, the way that our epistemology says is impossible. In this lecture, we've looked at a number of issues that are preliminary to any discussion of scientific explanation. We've done this by examining 8 topics. 1. Postmodernist, pragmatist, and realist conceptions of science. 2. The relation between scientific success and scientific explanation. 3. The relation between explanation, demarcation, methodology, and progress. 4. The uniqueness of scientific explanation. 5. How to investigate the nature of scientific explanation. 6. Investigative goals and proprietary terminology. 7. The relation between explanation and prediction. And 8. Traditional elements of scientific explanation. Thank you.